This is Dynamic Educational Hub. This is a channel where you learn physics, chemistry, and mathematics. If this is your first time of coming across my video on YouTube, kindly subscribe to my channel and click on the notification icon in order to get notified when I release new video. What are we going to learn today? We are going to learn vector multiplication of matrix, how to multiply two matrices together. Now, the first thing is we are going to look at multiplication of 2 by 2 matrix. When you want to multiply 2 by 2 matrix together, when you want to multiply them together, we have 3 by 3 matrix versus 3 by 3 matrix. We see how to multiply them together. We also see how to multiply 2 by 3 matrix and 3 by 2 matrix. Then we are going to see how to multiply 3 by 2 matrix and 2 by 3 matrix. Without further delay, let's start. Talk about vector multiplication of matrix. Now, vector multiplication of matrix is only possible if the number of columns in the first matrix is equal to the number of rows in the second matrix, e.g., matrix AMN and NC can multiply each other because the row of the first matrix corresponds to the second one. Let me quickly explain this. It's not all the matrix that you can multiply together when it comes to vector multiplication of matrix. You can only multiply a matrix in which the first one, the column, the number of column in the first matrix is the same with the number of row in the second matrix. For instance, let's look at this matrix AMN. It means that row M column N. For this one, row N column C. So for this to be, if these two matrices will multiply each other, it means that the value of N here, which happens to be our column, must be the same with the value of row here, which happens to be our row. You see N here as column, N here as row. So if you have 2 here, you must also have 2 here. If you have 3 here, you must also have 3 here. That is when vector multiplication of matrix is possible. That is when you can multiply 2 matrices together. Vector multiplication simply means you are multiplying 2 matrices together. While vector multiplication means, while scalar multiplication means you are taking a constant, you are multiplying it, you are expanding your matrix with a constant. So let's quickly look at example. I have various examples here. We have various sets of matrices here. We have matrix A of order 2 by 3, matrix B of order 3 by 3, 3 rows, 3 columns. If you haven't watched my video, the introduction to matrix, please kindly watch it because I've explained most of these things in the first video. Now this one is 4 by 4 square matrix, and this one is horizontal matrix 1 by 3. This one is also square matrix 2 by 2. This one is vertical matrix, which is 3 by 1. Now the question answer, which of the following matrices can multiply each other? So we want to see 2 pair of matrices that can multiply each other. Don't forget, in matrix operation is different from when you are doing your normal algebra. For instance, you can simply say that 2 multiplied by 3 will give you 6. And you can rewrite it the other way around as 3 multiplied by 2 will give you 6. You still get the same answer. But when it comes to matrix, it's another thing. Matrix has another property that is different from your normal algebra. So that is why AB in matrix will not be equals to BA. So we are going to see that in my next video when I explain properties of multiplication, vector multiplication of matrix. We are going to look at that. Now let's quickly look at this. Now the goal here is for any matrix to multiply each other, the column of the first one must correspond with the row of the second matrix. Now if I'm picking A, I want to check A. Now let's go. A, the column, I'm using color green as my row here, and I'm using color yellow as my column. So which means that these two must be the same. for any matrix to multiply each other. For A, we have the column here is 3, color yellow. I want to check it with B, and the row here is also 3. So which means that A, B and multiply each other. So we have A, B multiply each other. It's possible for A and B. So A, B, they can multiply each other. Now let's move to the next one, A, B. Now let's see if B, A can multiply each other. For B, A, so I'm picking the column here and the row here. So the value is not the same. You have 3 against 2. So it means that it's impossible. We cannot multiply them together. B and A. So B, A cannot multiply each other. Now if you carefully observe all these matrices, you observe that the C cannot multiply A because they don't have nothing in common. They have nothing in common. So let's quickly move to another one. We have A and F. Let's check A and F as well. Now for A and F, we see that the column of A corresponds with the row of F. So which means they can multiply each other, AF. Now let's see. FA, they can multiply each other. See, the column here doesn't correspond with the row here. So the two numbers are different. So which means they cannot multiply each other. It's only AF, not FA. FA cannot multiply each other. Now let's pick B. If you carefully look at all other matrices, you will observe that B can multiply F as well, because the column here corresponds with the row here. So that is why BF can multiply each other. B and F, BF. Now let's see if FB can multiply each other. No, they cannot multiply each other, which means that the column here doesn't correspond with the row here. So it's no for this. FB no, but BF yes. Let's check for B and D. For B and D as well. Sorry, I said B and D. Yes, B and D. Now for D, the column here corresponds with the row of B. So which means D and B, DB. Don't forget the first matrix, the row at the column must be the same thing as the row of the second matrix. So if this one happens to be first, so the column corresponds with the row of B. So that is why D and B. But B and D cannot multiply each other. So let's check. If you are not doing B and D, this is 3 here and this is 1 here. It is impossible. Now let's quickly check another one. We have another matrix here, which is E and A. You see 2 here, 2 here, the column and the row. So they can multiply each other. E and A, not A and E. So if you check A and E very closely, you see that they cannot multiply each other. Colon, then yeah. So those are the matrices. Those are the matrices that can multiply each other. We have AB, AF, BF, DB, and EB. If A is this matrix and B is this matrix, then AB is. Let's see how to find AB. To multiply two matrices together, it's quite simple. You multiply the row against the column. For the first matrix, pick the row, you multiply it with the column of the second matrix. What did I mean? For the first matrix, you pick the first row, multiply by first column of the second matrix, and that is going to give us a 1 1 multiplied by B1 1 plus a 1 2 multiplied by B2 1. After you've done that, still on the first matrix, the first row of the first matrix, you move to the second matrix and shift to the second column, and you multiply the two together again, and that is going to give you A11 multiplied by B12 plus A12 multiplied by B22. Now the next thing to do now is you will now shift from the first row to the second row. I'm talking about the first matrix now. After you have shifted to it, you will now move to the second matrix and pick the first column. Then you multiply the two together, and that is going to give you A21 multiplied by B11 plus A22 multiplied by B21. Still on the second row for the first matrix, you will move to the second column of the second matrix and multiply them together. What are you going to get? You are going to get A21 multiplied by B12 plus A22 multiplied by B22. You can compute your answer after you have done this. Then you can write your answer if you have values here. Now let's look at when you want to multiply 3 by 3. It's still the same procedure. You have your first matrix, you want to multiply with the second matrix. Now don't forget, you pick your row of the first matrix against the column of the second matrix, and you start doing it. A11 multiplied by B11 plus A12 multiplied by B21 plus A13 multiplied by B31. That is what we have here. You shift again, move to the next column, you do the same thing, what we have here. You shift again, move to the next column, do the same thing, what we have here. Now you are done with the first row. You move to the second row. You apply the same method again, do it. You apply the second method again, same method again, do it for this one. That is how to multiply square matrix together. Now what if we now have 2 by 2 multiplied by 2 by 3? You see, it is possible for us to multiply them together. Just check this number. 2 here, which happens to be column, correspond with 2 here, which happens to be a row. So we can multiply them together. It's still the same method. You pick your, this is going to be our answer, and then you pick your row for the first matrix against the column. It's as simple as that. You pick it, what you have here, multiply them, you move to the next column, do the same thing here, move to the next column, do the same thing here, then you can move to the next row. Do it for the first column, you have what we have here, the same thing, you have this, the same thing, and you have this. So finally 3 by 2 times multiplied by 2 by 3. So it's still the same method. So that is how we solve vector multiplication of matrix. When you have two matrices, you want to multiply them together. That is how you solve it. We have come to the end of the class, and in this class we are able to learn how to multiply two different matrices together, even though they are of different orders or they are of the same order. We're able to see 2 by 2 against 2 by 2, 3 by 3 against 3 by 3, 2 by 3 against 3 by 2, 3 by 2 against 2 by 3. Before I take my leave, I'd like to give you a simple exercise. Here is a question we can solve. Kindly solve this question and pick the correct answer. Comment it in the comment section. Let me see if you actually understand this. Now we have two questions here. We have A and B as shown. Find AB and find BA. Alright, thank you for watching this video, and if you haven't subscribed yet, kindly subscribe. See you in the next video. In the next video we are going to solve many examples. Alright, till then, bye.